Hi folks, Mr. Long here. This is a continuation of the derivative rules with no algebra with an emphasis on the chain rule. Okay, so we're going to emphasize the chain rule as we go through this. Okay, the chain rule. Whoops. And first thing we need to do is learn how to read composition of functions. And we've been doing a bit of this anyway, but there's nothing really new here. It's just, recognizing and applying the rules of BEDMAS. So let's start. So again, what you see here is composition. Composition just means a function inside a function, just like a composition in music, right? You have an overall score of the music, and then there are different instruments and pieces inside that score, right? So it's a composition of functions, it's just like a composition of music. Well, sort of. Okay, so let's look at this. What does BEDMAS tell us? BEDMAS tells us that we have to do the inside first, right? The inside brackets first. So if I see f of g at 1, and I've got all these values up here, that means that the first thing I need to do is figure out what is g at 1. So what I do is I go to x equals 1, and I go down, 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 down until I get to g. That's worth 9. So I know that I can replace g at 1 now with 9. So that's the same thing as f at 9. Well, now I go over to x equals 9, and I go down to get f, and it's worth 5. Okay, so that process is fairly clear. Do the inside, get that value, and then replace it and evaluate with f. Okay, so again, think of the way it works. You start with an x value, you apply the rule g. Once you get that answer, you take what that answer is, and you apply the rule f. Okay, so that's composition of functions BEDMAS. Okay, let's try another one here. And this one here should be b. So now what we're going to do is we're going to do f at h at 1. So again, what do I do first? BEDMAS tells us I do the inside. What's h at 1? H at 1 is, what's h? Oh, h is the graph. Let's go over here to h at 1. So there's our graph, and let's see. So I go to x equals 1. This graph is the rule h. I go up until I hit that point, and I go across, and it's 3. So h at 1 is worth 3. Okay, h at 1 is 3. So now I can replace h at 1 at 3. So I started with an x value of 1. I applied the rule h and got that answer. Now I have a value inside of f of 3. So now I have an x value of 3. I apply the rule f. What is the rule f when x equals 3? There's 3. The rule f is 1. Okay, so there's 3 parts to this, right? Start with the value of x. Apply the rule h. You get that answer. And then you have that answer, and now use it to apply the rule f. Okay, so you go from the inside out in BEDMAS. That's composition of functions. So we needed to do that in order for us to do the chain rule of calculus. Okay, so the chain rule of calculus, we're going to do it the same way. So these are derivatives. So what does this derivative mean here? That derivative means what is the slope of the function defined as g of f at x equals 1. Okay, g of f of x at x equals 1. That's what that means. I'm getting the tangent slope. So again, what we can do is we can look at this from an inside and outside perspective. There's the inside function, be like f at x, in this case it's f at 1, and then the outside function is g of f of x. Okay, that's the outside function. And often what we do with the chain rule is we can define this whole thing overall as like y equals. So y equals that. So what would the inside function be if I was going to use the chain rule? The inside function is, and we usually call it u, u equals f at 1. Well, what's the derivative of that? Du by dx equals f prime at 1. Then we have our outside function. Our outside function is y equals g at u, right? It's because the inside, I've called this f part, u. Well, what's the derivative of that? dy by du just equals g prime at u. But what is u worth again? U is worth f at 1. Okay, u is worth f at 1. So it's equal to g prime at f at 1. Okay, that's what that's equal to. Now, we know with the chain rule what we do. We multiply this and this. Okay, we multiply those two things. Now, what I want to do is I'm going to bring this right here down and rewrite it. So that means that g of f of 1, the derivative of that, equals f prime of 1, this right here, multiplied by g prime of f at 1. Well, which is just du dx by dy dx. But let's see if we can see a general pattern here. Let's look at this. So there's my inside. Oh, so if I write, and this prime out here means the overall derivative, right? That's the overall derivative. This is the inside derivative. So this right here is the inside prime. And then this right here is the g prime part here, which is the outside derivative. That's the dy by du. So if I look at this, I can just look at this and immediately write this. Inside derivative, outside derivative. Okay, and now let's use our tables to get an answer for this. So what is f prime at 1? What is f prime at 1? Well, I go up to the table, there's x equals 1, and I come down to f prime, and it's worth 1. So that's worth 1. Now I need to do g prime at f at 1. So over here I'm going to write f at 1 equals. Let's go back up and let's figure out what the function is worth at x equals 1. I go to x equals 1, I go to the f of x row, I get 3. That's worth 3. So now I can replace this f at 1 with 3. So I've got 1 multiplied by g prime at 3. What's g prime at 3? Again, go all the way up to that table, go across to 3, which is right here, and I go to g prime, all the way down here to g prime. So it's equal to 9. So it's 1 multiplied by 9, which is 9. So the overall derivative of g of f at 1 prime is 9. Okay, so that, folks, is our answer there. But again, what I want to reinforce to you is the way we can write this in function notation and save us a whole bunch of writing with all this u and du by dx. I mean, we still need to do this when we work with algebra, but when we're working with tables of values like this, it's a lot quicker to write it this way. Okay, so let's see if this time we can do it much quicker. So what I'm going to do here, so we're trying to get the derivative of f of h of 5. So we have a function, f depends on h, depends on x, and we're getting the slope when x equals 5. So what I want you to remember is that that's your inside, that part is your outside. What's the inside derivative then? H prime at 5. And then we multiply that by the outside derivative, which is f prime of h of 5. What do I need to do? Well, first of all, I need to get h prime at 5. Okay, h prime at 5. So, which graph is h? Or which, oh, that's the graph. That's the graph. So I go across over to here. I go to x equals 5, and I go up, up, to here, and I have to get the derivative there. Well, what's the slope of that segment? 0, right? That slope segment is 0. So I know the tangent slope there is 0. So that is worth 0 now. So we know our answer is going to be 0, but I still want to go through and finish this process off, just so you understand. Okay, so now I need to do h at 5. What's h at 5? I think we just were there. H at 5 is worth 9. Okay, so h at 5 is 9. So now I do f prime at 9. Where do I find f prime at 9? I go back to my table. I'm just going to erase this because it's so busy. So I want to do f prime at 9. I guess I don't need to erase that part of it. So there's 9. F prime is the second row. So it's 3. F prime of 9 is 3. So I go to here, and I'll have 0 multiplied by 3, which is 0. Okay, so f of h of 5, the derivative there is 0. But again, the key is this right here. Okay, it's doing that. The inside function is h at 5. We need to get the derivative, the inside derivative, h prime at 5. Then the outside is f of h of 5, so we need to get the outside derivative, f prime of h of 5. And then we multiply those two together. Okay? This requires another step, right? It will always require one more step because you have to evaluate the inside function first. H of 5 is worth 9, so I replace h of 5 with 9. Okay? And then 0 times 3 is 0. So folks, that is your derivative rules. No algebra for the chain rule. Very important stuff. I can almost guarantee you're going to see this again, whether it's an AP exam or an Ontario Final Calculus exam or university for sure. Okay, or even if you were doing technology in college, you would end up doing a calculus course and have to do stuff like this. All right, hopefully that helped. I know that was a long video. Have a good day.